Okay, grade 11s, let's take up these 3 homework questions, and this is basically going to end off all the work for this course. You've got one more quiz that you have to do after this. That's going to be just a couple of questions that look like these and some resistor calculations, and that's it. You're totally done. One thing I want to stress about these 3 homework questions is there are various different ways to do these questions because there's so many different ways you can think about the rules to solving circuits. I'm only going to do them one way and get some answers. Otherwise this video would be really long. You may have a completely different way of thinking about your rules in these circuits and getting the answers. First one says solve for the voltage at resistor 1. So the current is given at resistor 1. We need the voltage. The first thing you have to do is look around the circuit and see if there's anywhere that there are 2 numbers given in one spot, because then you can do Ohm's law. And Ohm's law is ultimately your goal here. If you can do Ohm's law once anywhere in a circuit, you can get every number in the circuit. But Ohm's law can't be done here, so you're going to have to think about your rules. You cannot do equivalent resistance because the resistors aren't given. In fact, the overall resistance of the circuit is already given. You cannot use your rules for voltages because it's a series circuit and 120 volts gets dumped off at resistor number 1. You don't even know how much is left for resistor number 2. So your only option is to use your understanding of current. In a series circuit, current doesn't divide. So if the current here is 6 amps, the current everywhere in this circuit is 6 amps. I'm just waiting for a noisy truck to go by. Geez, you know, that's one thing about COVID. I don't even live in a neighborhood where there's construction anymore, but every time I come out here to make a video, there's another truck going down the road delivering things. Okay, so 6 amps of current is the same everywhere in the circuit, and the best place to put that is right here. If it's 6 amps in this resistor, it's 6 amps at the battery. The overall current in the circuit is 6 amps. And then that allows you to look right here and say, now I've got 2 numbers in one spot, so I can do Ohm's law to solve for the third. So right here, voltage will equal IR. The current is 6 amps. The resistance is 30 ohms. That means that the overall voltage at the battery is 180 volts. Now you can very easily use your voltage rules, because that means that every electron that leaves the battery has 180 volts of energy that needs to be delivered, and 120 volts of energy gets delivered in resistor number 2. So that means that the voltage at resistor number 1 has to be 60 volts, because 60 and 120 add up to 180. And that's it for that question. The bottom one. In the following parallel circuit, solve for 2 values. We want to solve for the current in resistor number 1 and the current in resistor number 2. And they're not going to be the same because it's a parallel circuit. Current's going to split and go 2 different ways, and the resistors are different, so the currents will also be different, and that's why it's asking for both. There are 2 different ways you can approach this question, and like I said, I don't want to do it both ways. You could do resistor equivalence. You've got 2 resistors, a 20 and a 30 in parallel, so you could calculate the equivalent resistance of this circuit and use that at the battery. Or it's a little bit easier to say this is a parallel circuit and there's 120 volts of energy on every electron that leaves the battery. Some of the electrons are going to go down branch number 1 and back to the battery. Some of the electrons are going to go down branch number 2 and back to the battery. That means that no matter which electron you are, you only have one spot to dump off all of that voltage. So that means that the voltage at resistor 1 is going to be all 120 volts from the battery, and the the voltage at resistor number 2 is also going to be 120 volts, all dumped off at that battery. Then we can do 2 separate calculations. for these, since now you have two numbers in one spot, you can use Ohm's law, V equals IR, and rearrange it, I equals V divided by R, and just sub in the numbers. So for this first one, we're going to have 120 volts divided by 20 ohms. That means that this current is 6 amps. And over here, same calculation, just different numbers. We have 120 volts divided by 30 ohms, which means that the current going this way is going to be 4 amps. So as a quick check, if some of you did do equivalent resistance and solved for the equivalent resistance and then calculated the current at the battery, you would have gotten 10 over here. I'm not going to do the calculation that would lead up to that, but 10 amps would be the current at the battery, and then it splits into 6 and splits into 4 based on these other numbers. Last question. In the following series circuit, solve for the voltage of resistor number 3. So we want this here. What is the voltage of resistor number 3? A quick glance at this circuit. Current's not given anywhere. That would have been nice. It's a series circuit, and current's the easiest thing to use in series. But current is not given. The voltage is given as 100 volts, but that means that bits and pieces of this 100 volts is going to be dumped off at 3 different batteries, and they're going to be 3 different values. So that won't help. The only thing that you can do here is look at the resistors and do equivalent resistance. So it's a series circuit. In a series circuit, you add up the resistors. I would write out the calculation, but this is just a take up. So 30 plus 30 plus 20 would be 80 ohms total. And you always write your equivalent resistance over here at the battery. So the overall resistance of this circuit, I see that there's a missing voltage here. The overall resistance at the circuit is 80 ohms. And even though this is not the spot where you need to solve the answer at the end of this question, this is really the only place that you have any numbers to work with. So you've got 2 values here, right here at this spot. Let's do an Ohm's law calculation and solve for the missing value. I equals V divided by R. The voltage is 100 volts. The resistance is 80 ohms. And I'm going to use a calculator because I want to make sure I get that right. 100 divided by 80 is 1.25. So there's 1.25 amps of current flowing out of the battery. And this is a series circuit. So that means that 1.25 amps is going to be 1.25 amps everywhere in the circuit. And when the current flows through resistor number 3, it's still going to be 1.25 amps. But now I have 2 numbers right here on resistor number 3, and I can use Ohm's law again with these 2 numbers. The voltage here will be IR. And then the current is 1.25 amps. The resistance just at this resistor is 30 ohms. And on a calculator, 1.25 times 30 gives you the overall voltage, 37.5 volts, to finish that question off. If you were to quickly check the voltages of the other 2, you would get 2 other numbers where all 3 of them would add up to 100 volts. But this question's only asking for that one. So that's the only answer you need to finish the question off, is 37.5 volts. If you don't understand any one of these 3 questions and you want to go through it in more detail, I can do that one-on-one with you. Just email me, or I guess Gmail me on the board's Gmail. The only thing left, if you understand these circuit questions and you feel like you've got it, is I'm going to post one more quiz tomorrow. It's not going to be long. It's just going to have a couple of questions like these, and it's going to have a couple of resistor calculations like the homework from yesterday, and that's going to be it. That will be it for the entire year, and I will calculate your grade, send it to you with a report card comment, and you'll be done the course.